My name is Leah Emery, and today we are going to be talking about Amedeo Avogadro. He was born in 1776 and died in 1856, and he is known for different equations that apply to gas laws. He's also known for Avogadro's constant, which we all know as 6.022 times 10 to the 23rd. And he plays a big role in many gas laws. And this consists of T, temperature. Let me find my marker here. We have T represents temperature, V represents volume, P represents pressure, and N, which represents moles. Now, Avogadro's law is more concerned with volume and the amount of moles. And what this is basically saying, if we rewrite this, is volume is directly proportionate to the number of moles. So with these three factors, it can be rewritten or therefore calculated by V1 over N1 equals V2 over N2. So, and this can be explained, say, in a real world concept with your balloons. You're airing up a balloon. As you're blowing into the balloon, we are adding more gas to the balloon, represented by N. And in order for the pressure and the temperature to stay the same or constant, the volume has to expand to accommodate the extra gas. So that is also represented with the V1 over N1. So let's add this to a real life concept. A 4-liter balloon filled with hydrogen gas contains 2.80 moles of hydrogen. Assuming constant temperature and pressure, which is here, we're just not gonna add that in the problem here. We're focused on volume and the number of moles. So assuming constant pressure, how many moles of hydrogen must be added to obtain a final volume of 22 liters? So we have our three factors here, but don't forget it says how many moles of hydrogen must be added. So we already have this amount here, and that's important for the answer at the end. So let's plug this in. We have V1, N1, V2, N2. First, we are going to identify our equation, and we have 4.00, which is volume 1, over 2.80 moles of hydrogen gas. And this is equal to the final volume of 22.0 liters. There. So N2 is how many moles of hydrogen must be added. So this is, moles is what we need to find. So let's plug this into our calculator, and it can be more simplified like this. Don't forget your units. So we have liters on the top, liters on the bottom, cancel them out. And that would equal 15.4 moles of hydrogen gas. But we're not done yet, because the question was how many moles of hydrogen must be added. So we're going to do 15.4 subtracted by 2.8. And remember sig figs, it's going to be 12.6 moles of hydrogen gas. And there you have it.